Okay, so let's continue with our solutions on some questions on ordinary differential equations. So today we are going to look at question 18, 19, 20 going. But let's look at the first three and see. So we are asked that find the integrating factor of the equation. And what is the equation? The equation is x squared plus 1 dy dx plus y equals x e power x. We are asked to find the integrating factor. This is a first order, which you can write in the standard form by dividing through by x squared plus 1 over x squared plus 1 and here over x squared plus 1. So this and this will go, so we have dy dx plus 1 over x squared plus 1 y equals to x e power x all over x squared plus 1. And so now this is our p of x, remember, and we know that the integrating factor is given by mu of x equals to e power the p of x, which is 1 over x squared plus 1 dx, and we know that the integral of this is just tan inverse, so that will just be e power tan inverse of x. Okay, by looking at our options, we don't have tan inverse, we have e power a tan x. If it was e power arc tan x, okay, that would have been the answer, but this one is not the answer, so don't think the answer is there. So it's none of the above because the answer is not there. Okay, so that is just e. So 18 is e. Now let's look at 19. Said we should solve the IVP, and the IVP is dy dx equals to cos x plus y, where y of 0 is equals to pi over 2, like this. And so this one we have to just do substitution to solve it. So we can say that let u equals to x plus y, so du dx is equals to 1 plus dy dx, making dy the x the subject. We have dy dx to be equals to du dx minus 1. Doing our substitution, we have we know it's dy dx to be equals to cos x plus y, but x plus y is u, dy dx is now this du dx minus 1 equals to cos u, and so we have du dx to be equals to cos u plus 1. This is separable, and so this will imply we have du dx to be equals to, sorry, let me do this. I just want to separate, so that will just be cos u plus 1 to be equals to dx, like this. And solving this, this one you can solve it by half angle substitution, or you can multiply by the conjugate pair of this. Okay, this is just calculus, so if you multiply by the conjugate pair, that's just 1 over cos u plus 1 times cos u minus, sorry, so let me just make it 1 plus, or either way it is correct. Let me make it this one, 1 plus cos u, so that 1 plus cos u, so 1 minus cos u, that's the conjugate, over 1 minus cos u. So we just want to integrate this, so we have 1 minus cos u all over 1 minus cos square u and this one here is sine square u. So we have 1 minus cos u over sine square u. Dividing through, we have 1 over sine square u minus cos u over sine square u. But this one here is cosec square u minus this one here will be cosec u cot u, like this. So we want to integrate this thing. We want to integrate this. Okay, and so integrating this one, if we integrate cosec squared, what are we getting? If we differentiate cot, okay, if we differentiate cot, we get negative cosec. So now if we are having cosec squared, then it means we have differentiated negative cot. So the answer for this integral will just be negative cot u, and for this one, that's cosec, negative cosec cot, that's the differential of cosec, and so integrating negative cosec cot, that just gives us cosec. So plus cosec u plus c. So this is our x. This one is equals to x. Okay, or we can just make it the x, the c will come here, all is the same. So negative cot u plus cosec u is equals to x plus c, all is the same. Now but we know that u was equals to x plus y, so we do back substitution. So that will just mean that we have cosec x plus y minus cot x plus y equals to x plus c. I just interchange the position of these two, doesn't matter. But it is an IVP. They said that they said this y of 0 equals to pi over 2. So we substitute that inside to find our c. So we have cosec of 0 plus pi over 2 minus cot 0 plus pi over 2 goes to 0 plus c, like this. And so here, what do we have? So here cosec of, so this one will just be cosec pi over 2, and cosec we know is 1 over sine, so that's just 1 over sine pi over 2, and sine pi over 2 is 1, so here is 1 minus. Now cot is just cos over sine, okay, and so cos 90 over sine 90, sine 90 is 1, cos 90 is 0, so here is 0 equals to c. So our c is 1. So therefore we can say that we have cos sec of x plus y minus cot x plus y equals to x plus 1, because our c is now 1. It's now 1. So this is our answer from that question, and that's 19. So the answer there is D. Okay, so 19 D. So we look at 20. This is a very simple one. Let me not go far, I'll just be here. So they said the population of a particular community is observed to increase at a rate proportional to the number of people present at any time. In the last 5 years, the population has tripled. How many years will it take for the population to grow 5 times of its initial population? Of course, you should know these problems by now. We know that um, the P, the T is equals to RT, like this. And we always know that P of 0 is equals to P naught. And solving this, you have P of T equals to P naught e power RT. You should know this by now. So here they are saying that in the last 5 years the population has tripled. It means P P naught in the last 5 years, in 5 years time, 5 years, it will become 3 P naught. It has tripled. That's just the meaning. So we have P of 5 equals to 3 P naught. Okay, and so if we know this, then we can say that, but what is P of 5 using this model? That's P naught e power R of T. The T is now, the time is 5, so 5. So here we will get 3 P naught equals to P naught e power 5R. So we can divide both sides by P naught. So that will just give us 3 equals to e power 3R. Taking ln of both sides, ln 3 equals to ln e power 3R. And so if we do that, taking ln, so we just get 3R to be equals to ln 3. Sorry, is it 3R? 5. Yes, 5, sorry. Because the time was 5. 5. 5R. Okay, so R is equals to ln 3 over 5, like this. So it means our model, our P of T, will just be equals to P naught e power. Our R is now ln 3 over 5. So that's just ln 3 over 5t, like this. Now, what are they saying? How many years will it take for the population to grow 5 times of its initial population? So we will look for t when we have 5 p naught. Okay, so 5 p naught is equals to p naught e power ln 3 over 5t. And solving this, we divide here by p naught first, p naught. So we have 5 equals to e power ln 3 over 5t. Taking ln 5 is equals to ln e power ln 3 over 5t, like this. And so we will now have, this will give us 1, this will give us 1, and so we will have ln 3 over 5t equals to ln 5. Our t is equals to ln 5 over ln 3 over 5, and now t is equals to, using your calculator you get 7.3. okay, that was just 7.3 years, and our answer there is C. So question 20, the answer there is C. Okay, so let's look at question 21, 22, and 23. So the question 21 reads like, but it's like a compound. We are using the information to answer 21 and 22. So a breeder reactor converts relatively stable uranium-238 into the isotope plutonium-239. After 15 years, it is determined that 0.043% of the initial amount A0 of plutonium has disintegrated. Okay, so here we don't need to be modeling the equation. We just have to write the model down, and we all know that dA dt is equals to kt. So where this A is the amount remaining, and we know that A of 0 is equals to A naught. And when we solve this, we have A of t equals to A naught e power kt, like this, where the k is the constant of disintegration and t is the time. And so, but from the question, they are saying that after 15 years, it is determined that 0.043% had disintegrated. So if this has disintegrated, okay, then what is remaining? The remaining will equals to 100 minus 100% minus 0.043%. And when you do this, then you get 99.957%. And so in decimal terms, you divide here by 100%, and so that will just give you divided by 100, just get 0.9995, like this. And so we are saying that what it means is at A of 15, this will become 0.99957 of the A naught. That is the meaning. Okay. And so writing the equivalent of this will just be equals to A naught e power 15k, like this. Okay. Because the time given was 15 in the question. So this implies that we have 0.99957 equals to e power 15k. And now solving for k, we have 15k to be equals to ln 0.99957, and this will imply k is equals to ln of 0.99957 over 15. And so ln of so we have ln 0.99957 divided by 15. That will just give you this is approximately equals to 0. It's negative 0.0000286728311 going. So this is what it is, but it has been approximated to be negative 0.0000029, like this, based on the answers we have in the question. So therefore we can write our A of t to be equals to A naught e power the k is now this negative 0.00029 t. Okay. So that is all that we have to do, and based on that, our answer is C. So our answer is C. Okay, so C is our answer. Now let's look at find the half-life of this isotope. So what do they mean by half-life? So half-life is the time taken for half of the substance of the A naught of this one to disintegrate. Okay. So but we don't know the time. So it is that time that we are looking for. So the half-life, so that will imply that half the time required for half of the substance to disintegrate. So this will just be a naught e power negative 0.000029, like this, 29 t. So we just have to work out the t. So we divide here by a naught, here by a naught. This and this will go. So we get 0.5 equals to e power negative 0.000029 t. We take ln 0.5 equals to ln e power negative 0.00029 t, like this, and so this will drop. So that will simply mean that we have negative 0.00029 t equals to ln 0.5 divided here by 0.0000029 here over negative 0.0000029, and this will go. Therefore our t will be equals to, well, let's see, ln 0.5 divided by negative 0.0000029. So based on this answer, we are getting something like 24,180 years. Okay. So this is our answer, and that is A. So number 22, the answer is A. 23, a question is like, if we have y prime 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 plus 6y prime prime plus 12y prime plus 8y equals to x plus e power x sin x. So we are asked to write the form of the particular solution, or the form of this particular solution. So always you just have to solve this part first. If you put this in your calculator to solve, I think you are going to get, let me see, putting it in the calculator, you get okay, 1 equals 6 equals to 12 equals to 8 equals, so you get x to be equals to negative 2. So that's just x plus 2 power 3. So where the 2's are up to 3. And looking at this, it will not affect the solution. So because of that, you can easily write it. So this is a linear function. So our y of p can be written as ax plus b. That's for this part, and then we have plus let me see, a power x, that one multiplying by this, that will simply mean we have maybe m sine x plus n cos x, like this, because the form of this is x. Okay. So based on those answers, then we can just say that the answer is I think that will be B. Yeah, that will be B, because this and this can all be turned as one constant, multiplying them. So we can just bring it out as C here, and so the answer there will be what? B. Looking at the available answers in the question. So the answer is B. B. So let's go to the next set. That will be 24 going. Okay. So question 24. Question 24. It's kind of let me clean this part. D of 5, sorry. D5 y d x5 equals to x. So we are asked to find the general solution of this. So here we first integrate, we integrate for the first time. So integrating, we get d of 4 y d x power 4 equals to, so here I get x squared over 2 plus c1. We integrate again, that will be the 3y dx 3 equals to x power 3 all over 6 plus c1 x plus c2. Okay, then we integrate again, so that will be the 2y the x2 goes to x power 4 over 24 plus c1 x squared over 2 plus c2 x plus c3. Let me clean this. Okay. Okay, so we integrate again, integrating to have dy dx equals to this one, x power 5 over 120 plus c1 x power, sorry, here's over 2. Yeah, so x power 3 all over 6 plus c2 x power 2 over 2 plus c3 x plus c4, and we integrate for the last time. So integrating for the last time, that is y to be equals to x power 6 over 720 plus c1 x power 4 over 24 plus c2 x power 3 over 6 plus c3 x power 2 over 2 plus c4 x plus c5, like this, plus c5. So we have a very long answer in this form. It is this one here. Yeah, so looking at the answers that we have on the paper, I think that will just be okay. So that will just be, I think that will just be C. That will just be C. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, that will just be C. Don't worry about the constants here, because C1, C2 are just constants, and the 1 over 6, 1 over 24 are just constants. So don't worry about them. We are just interested whether there is a constant or not. So this one can be one constant, can just represent with C1, this one C2, okay, in that order. But here there was nothing like that, so we have to write it in full. So the answer there will be C. Okay, so that's question 24. Answer is C. Now look at question 25. Number 25. Let me clean this part. Okay, so we have question 25. They said the characteristics equation of the first order differential equation is given by, so they've given us the characteristics equation, which is like lambda squared minus 4 lambda and plus 13, all of that squared equals to 0. Okay, so here if you use calculator to solve what is inside, I think you will get something like 2 plus 3i, so the conjugate pair of this. Okay, but there are two because the thing is squared. This one will give us what is inside, but there are two. Okay, so it means we have, because we are supposed to get 4 answers, since the characteristic equation will be a 4-fold equation. So because of that, we are going to write the equation in this one. You know that the equation is always written like y of x equals to e power alpha x to brackets c1 sine beta x plus c2 cos beta x, where alpha is this 2 and beta is this 3. Okay, but this one has a multiplicity of 2. It has a multiplicity of what? 2. Okay, so because of that, it simply means that we write this as e power, our alpha is 2 x into brackets c1 sine 3x plus c2 cos 3x. This is one of them. Now plus, since it is a multiplicity of 2, x e power 2x, another one c3 sine 3x plus c4 cos 3x, like this. Okay, but here you know that we can group the causes. Okay, so that will simply mean that we will now have, if we group the cos, that will mean we have e power 2x into brackets. Okay, let me group the signs first, this and this. That will just be c. Okay, so let me clean this because the sign is common. So sine 3x into brackets c1 plus x c3 or c3x, now plus e power 2x cos 3x into brackets c2 plus x c4, like this. Okay, and so if you take your time to check, I think the answer there will be C. That will be C. So yeah, the answer there will be C, because after all they factorize this one to out, which is common to both, and that's true. Okay, yes, so you can just write it as e power 2x in big brackets like this. Then you have your c1 plus x c3 sine 3x plus brackets c2 plus x c4 cos 3x, then you close your big bracket like this. And that is what they did, obviously. Thank you. So we are going to question 26. Question 26. So let's see. Question 26. Okay, number 26. Let me change my color. Okay, now we are going to blue. So question 26, it is Cauchy-Euler x cubed y prime 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 minus x squared y prime prime plus 2xy prime minus 2y equals to 0, where x is greater than 0. Okay, x is greater than 0. And so we can write the characteristics equation of this, because this is a Cauchy-Euler. If we write the characteristics equation, this will just be lambda minus 2 lambda minus 1 lambda minus 2 brackets lambda minus 1 lambda plus 2 lambda minus 2 equals to 0. Simplifying this, if we simplify this, think we are going to get lambda cubed minus 4 lambda squared plus 5 lambda minus 2. If you do all the expansions, you are going to arrive at this. So solving this, lambda will just be equals to lambda will be equals to, I think we are getting something like let me see. I think we'll get lambda to be 1 1 2 or so. Yeah. Let me check. So that will be 1 equals to minus 4 equals to 5 equals to minus 2. So get x not to be 2 1. Yeah. So we get something like that. Yeah. So the one has a multiplicity of 2. This one has a multiplicity of 2, and so because of that, writing our solution in a Cauchy-Euler form, we have y of t to be equals to c1 e power t plus x, sorry, not x, t. It is c2 t e power t plus c3 e power 2t, like this. So but we do our substitution, we know that t is equals to ln x. So this will mean that we have c1 e power ln x plus c2 ln x e power ln x plus c3 e power ln x. So this and this will go. That will mean we have c1x. This and this will go. We have c2x ln x. This and this will go. Sorry, this is 2. There's 2 here. Okay, so that will just mean the 2 will come here. And this and this will go. Now will just be plus c3 x squared, like this. Okay, and so can put this one in absolute value sign. So the answer there is D for our question 26. Okay, so 26, the answer is D. Now I'll go to 27. 27, they are saying that we should compute the Wronskian of the solution. So what do we mean by the Wronskian? W of x equals to, we just have to find the determinant of the solutions. First one is x, second one is x squared, third one is x ln x. Okay, so differentiating this, we have 1, 2x. This we use product rule, so keep the x while we differentiate this, and that will just be 1 plus, we are keeping the ln x while we differentiate this, that will just be ln x. We differentiate again, this is 0, this is 2, this is just x power negative 1, because when we differentiate you get 1 over x for this part, and this will go to 0, so 1 over x is the same as x power negative this. Now if you do this, you find the determinant of x into brackets, we have 2x 1 plus ln x 0 x power negative this minus x squared, then we have 1 0 1 plus ln x, then x power negative 1 like this, then plus x ln x brackets 1 2x 0 2 like this. And so that will simply mean that this and this, we have x into brackets 2 minus 0, sorry, minus 0, it was this column and this column, so that will just be 2, here is 2. Okay, so 2 minus 2 plus 2 ln x like this, then here I'll get minus x power 2 into brackets x power negative this and this give me 0 minus 0, then plus x ln x to brackets, this one I'll get 2 minus 0. So here I'm going to get 2x minus 2x plus 2x ln x minus x plus 2x ln x. Is this minus? Oh, here's minus. Yes, minus. Yeah, because this place was minus. So this times this, everything is minus. So that will simply mean that, yeah. Here I'll get 2 minus, everything there will be minus. So here will be minus, here will be minus. Yeah. Okay, so this and this will go. Yeah. This and this will go. Okay. Yeah, so x ln. Okay, so here everything goes leaving negative x, but in our options we don't have negative x. The only answer close to it was x, but that one too is not negative, so we will have to take none of the above. So that's just E. I don't know whether I made a mistake, but I don't think I made a mistake. So that is just E. So E is the answer. They are saying we should compute the Wronskian of this. So here we will use Lovelace's formula. which is stated that the Wronskian is equals to W naught e power negative p of x dx, like this. And so our p of x is just cos x, so that would just be W naught goes to negative integral of cos x dx. And so integrating this, if we integrate cos x, we get sin x, so that will just be e power negative sin x, like this. Okay, and so the answer there will just be C. So for 28, the answer is C. Now 29, they are saying that you should compute the particular solution of this, which is y prime 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 equals to sin x. Okay, they are saying we should compute the particular solution. So we just assume that the particular solution is y of p is equals to a sin x plus b cos x. So differentiating this, y prime will be equals to a cos x minus b sin x. Y prime prime is equals to negative a sin x minus b cos x. Y prime 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 is equals to negative a cos x plus b sin x. So substituting, this will imply that we are substituting this one into the differential equation because it only contains that one, and compare. So let's substitute. That will be negative a cos x plus b sin x all equals to sin x. Comparing, if we compare, b will just be equals to 1 and a will just be equals to 0. So this will imply that we have our y of p to be equals to substituting it back into this, a is 0, b is 1, so that will just be b cos x. So b is 1, that's just cos x. So y of p is just cos x, and that is b. So 29, answer there is b. Now go to 30, which will be the last one under the objective part. So the roots of the characteristic equation of the homogeneous part of this equation is this given by this. If using the method of variation of parameters, the form of the particular solution is this, find the function this. So this is variation of parameters. So and then so let's look at the last question, which is question 30. We are saying that the roots of the characteristic equation of the homogeneous part of the second order Cauchy-Euler equation x squared y prime prime minus 2xy prime plus 2y equals to x cubed sin x is given by lambda 1 equals to 1 and lambda 2 equals to 2 if using the method of variation of parameters. The form of the particular solution is y of p equals to u of x, u1 of x plus u2 of x squared plus, I find the function u2 of u2 x. So this one, it is simple. We just have to find our Wronskian. You know that Wronskian is equals to, so we were given the solutions of, so this one is actually maybe your y1, y2, y1 prime, y2 prime, y2 prime like this, but our y1 given was x and our y2 is x squared. Differentiating them, we get 1 and then we get 2x like this. So if we calculate further, we just get this one will just be 2x squared minus x squared, and this is just x squared. So this is our Wronxian. So to find W2, we just need W2, we don't need W1, the second Wronxian. So with that one, we just replace so the first column of this one, we leave the first column. It's like you employing what we call the Cramer's rule. You know what you do. We need the second variable, so we just have to replace the second column with the constant matrix. Constant matrix in that case. And our constant matrix from the question would have been, let's say, if we have that would have been x squared y prime prime minus 2xy prime plus 2y equals to 0. This is 0, and then the other part is x cubed sine x if it was the particular solution, the original thing. So this is the constant matrix, and so we will leave the first column, which is just x1, then replace the second column with 0 and then x cubed sine x. So here we just have to find the depth of this. So this will have x power 4 sine x minus 0, and this is just x power 4 sine x. So this is our second Wronxian, but our u of 2 prime is equals to the second Wronxian over the Wronxian, and the second Wronxian is just x power 4 sine x over the Wronxian itself is just x squared like this. We calculated it up here, it's just x squared. So this will imply we have x squared sine x like this, and so we just have to integrate u prime of 2 equals to integral of x squared sine x. So integrating this, we just get u of 2 equals to, but here we just have to use integration by parts. So I can just write x squared sine x, this one x 2x, this one is cos x 2 negative sine x 0 negative cos x, and this goes plus minus plus. So this becomes x squared cos x plus 2x sine x minus 2 cos x. Okay, so we check our answers and see, do we have x squared there? Do we have x squared? Yeah, we have some x squared, but it's negative. Okay, so we have some x squared there, but all of them are negatives. So you see, that would have either been A or C. You see, that would have been A or C. Based on what we are having, that would have been A or C. But it will not work that way. So we will have to take none of the above, because either of them, this term is supposed to be negative and this term is supposed to be positive. Or if I multiply by negative, if I multiply through by negative, it will not work. it will not work. Yeah, so multiplying through by negative, that would have been which one? Oh, none. The answer is actually none of them. Yeah. So none of the above is the answer. So question 30 is E. So if we go back to 30, that's just E. Yeah.